Good morning, guys, and welcome to Mind Your Math. Today, we are going to talk about spheres, find out the total surface area, as well as the volume of the sphere, which I might do in the next video. And while talking about spheres, we will also talk about hemisphere. Okay, so now let us first, let us define what a sphere is. So let us get to the definition of a sphere. Okay. Suppose I'm standing over here. So when we are talking about sphere, you have to understand that we are talking about three-dimensional space. It is not a two-dimensional space as in a plane. We are not talking about a circle. We are talking about three-dimensional space. So I'm standing over here, and suppose this at this arm's length, if I am collecting every single point which is at this arm's length, okay, like this, like this, like this, and all around me. Assuming I was so flexible, I can collect turning by, I could collect everything. All those points combined together will give me a sphere. So sphere is basically the set of all points which are at a fixed distance from a given point in space, not in a two-dimensional plane. Okay. Now, when you have a sphere like that, you know that there are points inside the sphere which are not at this distance, but they are at a slightly smaller distance, because what I'm doing is I'm collecting all the points. So the points which did not even want to be part of the sphere also gets collected. So there are points inside the sphere which are not at the same distance. Me being the center, if somebody is going to draw a line or insert a rod through me so that it reaches the other end of the sphere, I become the diameter of the sphere. And if you take this entire length from this end to this end, it will give you the measure of the diameter. Keeping me as a center, if you take the length from this to the end, you will get the radius. It's plain understanding, just like a circle, except that we say that sphere is in a three-dimensional space, and half of the time students always forget that sphere is in a three-dimensional space and they compare it to a circle and do the sum. Never mind. Okay, so you know what is the diameter of the sphere, you know what's the radius of the sphere, you know the definition of the sphere. Now we need to know the formula for the sphere, and we need to know what is a hemisphere. Now suppose you have a big ball of ice cream which is in the shape of a sphere, correct? Now that ball, you need to divide it between you and your friend in by half, exactly half. So you take a knife and cut it along, along the plane in such a way that both the measures are exactly the same. Then you get two hemispheres. Okay, so now this is one solid where you don't have to learn how we have gotten the value of the formula or how we have gotten the formula. We just need to by heart the formula. The reason being, the follow-up to reaching the formula is beyond your particular class, so you just need to by heart the formula. So the total surface area of a solid sphere is given by 4 pi r square, where r is the radius of the sphere. Now I told you that whenever you are slicing a solid sphere into two equals, you get two hemispheres. When I'm trying to find out the area of a hemisphere, I can see that there is a surface that has been added to the hemisphere. That's the base part of it. See, this is our sphere. So I told you area is a space where I can run my hand. So if I take a ball, I can run my hand on the surface. So that gives me 4 pi r square. That is area of a sphere. Now, if I'm breaking the ball into two parts, I can run over it and on the base also. Correct? So I have got two surfaces over there. One is called as a curved surface and other is called as a base. Base is a circle whose area is given by pi r square, where r is the radius of the hemisphere, and the curved surface area is exactly half of this, which is 2 pi r square. So in total, I get 3 pi r square as the area of a hemisphere. Okay, so that is one thing you have to be very careful about when you're talking about a hemisphere. We are not talking only about the curved surface over here, but there is a base which is a circle where we can run our hand. So in the case of the area, it is not just 2 pi r square. We need to add the base area also, which is 3 pi r square. But you should also know how to split it as 2 pi r square and pi r square. Suppose they are asking you to find only the curved surface area, you should know that you need to find only 2 pi r square. Okay, so now let us do a few sums. After that, after getting very clear with this particular two concept, we will move on to the area of a spherical shell. Here I have written three sums. The first two are very direct. Find the TSA of a sphere of radius 7 centimeters. So you know that formula for the total surface area of a sphere is given by 4 pi r square. You substitute it directly 4 into 22 by 7 into 7 into 7. Okay, and find out the answer. Find the TSA of a hemisphere of radius 4 centimeters. So you know that the TSA of a hemisphere is given by 2 pi r square plus pi r square, which is 3 pi r square. Again, it is a direct substitution of the values. Okay. A sphere and a cylinder are of the same radius and height. Find the ratio of their area. So you have been given two solids whose ratio of the areas we need to find. So what is the data that is given to you? Absolute values of measurements are not given to you. They have just said that sphere and a cylinder are of the same radius and height. So if this is our sphere, this is our, this is our. This is our cylinder. This is our, because they are of the same radius. And it is also said that they are of the same height. So which means that the height of the sphere is given by 2r, or I can say that the height of the sphere is actually the diameter of the sphere. That is equal to the height of the cylinder. So I can say that h is equal to 2 times r. Okay. Now what do we need to find? We need to find the ratio of the areas. So what is the area of a sphere? 4 pi r square. It is not going to change. What is the area of a cylinder? I know that the area of a cylinder is given by 2 pi r square plus 2 pi r into h. Now let me substitute. My radius is r itself, but my height is actually what now? It is 2r. Now let me cancel out the common factors if I am having any. Correct? Or I am getting 4 pi r square by 6 pi r square, or my radius becomes 4 by 6 or 2:3. Okay. Now the important point in this particular sum is to understand that the height of the cylinder is actually equal to the diameter of the sphere. So if you're having a doubt like that, if you're not able to figure out, draw the diagram and see. See, that is the reason I always tell my students, or I make them draw rough diagrams whenever we are doing a sum, even if it is a very basic sum like this. I ask them to draw the diagram. So whenever I am giving a worksheet to them, or whenever I am doing a particular sum in the class, they totally resist it because they do not want to spend that extra time doing something, a proper cylinder. What they do is that they do something like this and mark. But what you need to understand is that unless that visual, observation is there or visual understanding is there, it is never going to get easy to do any sums. A right circular cylinder just encloses a sphere of radius r. Find the surface area of the sphere and the CSA of the cylinder. A diagram is given to you. The diagram which is given to you in the book is a proper one. This, okay. So we need to find the surface area of the sphere and CSA of the cylinder here, right? So what is given to us? The radius of the sphere is given to us. Okay. This is also r. So what can I say about the height of the cylinder? It is equal to 2r. Okay. Now we need to find the radius of the cylinder, which is this part. From here to here also I can say that the value is r because it is a radius of the sphere. So radius of the cylinder is r. So we have gotten all the terms that we need to we require to calculate the area. So what is the area of the cylinder equal to? It is 2 pi RH, because we need to find only the CSA of the cylinder. So 2 pi, what is the radius? It is equal to r. And what is the height equal to? 2r. So you will get 4 pi r square. Now what is the radius of the sphere equal to? What is the area of the sphere equal to? Because we need to find the total surface area of the sphere. That is also equal to 4 pi r square. So you can see that the area of the sphere inside a cylinder which just encloses it will be the same as that of the curved surface area of the cylinder. Okay, from this question, that is the inference that we draw. If you are dropping a cylinder, if you are dropping a sphere into a cylinder that just exactly covers it or encloses it, you can see that the total surface area of the sphere is exactly equal to the curved surface area of the cylinder. This is a result that you should remember, because See, it is not just for your particular board examination, even if it is for your examination also, if this fact you remember, you know that this is what is the answer that I am supposed to get when I am doing this particular sum. So when you are getting, results like this from any of the sums, please memorize it. The diameter of a sphere is decreased by 25%. By what percentage will the CSA decrease? Now, it's an extremely easy sum, but the thing is that most of the students find this particular sum difficult. Maybe it is a framing of the question, or maybe it is that there are no specific values. This sum, it is not unlike the ratio sum. Ratio sums many of the students can do, but this particular sum, there are students who make mistakes and many of them try to by heart the whole thing. Let us now break down the sum into parts so that you can deal with any kind of sum that is similar to this. What is given to us? It is given to us that the diameter of a sphere is decreased by 25%. So if you had a sphere like this, the sphere was changed to something like this. Okay. Now, if the original sphere had a radius of r, there is a 25% decrease. You need to understand that the diameter of the sphere did not become 25%. It is decreased by 25%. So read the question properly. So which means that if you had 100 rupees and somebody were to take 25 rupees away from you, what would you be left with? 75. So similarly, R was the original radius. And one more thing you need to remember is that whatever changes you are making to the diameter, without any hesitation, put the same changes in the radius also, because it will exactly reflect on the radius. So whatever changes or 25% decrease in the diameter, radius also will decrease by 25%. Okay. Now, radius, the initial one was R. Now, there is a 25% decrease. 25% when I convert it into fraction, 25 by 100 R got reduced from the original radius. What is my new radius? It is 75 by 100 into R. Okay. Now, you can write it as 0.75 R if you are okay with decimals. Or what you should do actually is that reduce this 75 by 100 into a number that is easy for us. Now 75 by 100, if you are dividing or taking out the common factors, you know that it will get reduced to 3 by 4R. It's much easier and it's such a relief to reduce this number to 3 by 4R and then get out with the sum. Okay. So we had a radius R, 25% is gone. The new radius is 3 by 4R. Now let me ask you, original radius is R. There is a 80% decrease. What is my new radius? It has to be 20 by 100 into R, because 80% is gone. Reduce it. What will I get if I am reducing it? I will get 1 by 5R. That is my new radius. Okay. Suppose the question was, the diameter of a sphere is decreased to 25%. So what is my new radius? It is 25 by 100 into R. Please read the question properly. It is just the difference of a small word, by and to. By 25%, you need to reduce. Understand the question. It is reduced to 25%. The radius became 25 by 100 into R. Accordingly, take the new radius and the original radius. So, in this particular sum, we have gotten 3 by 4R. Now, by what percentage will the CSA decrease? Now, what you need to know is that they are not asking you to find the ratio between the original and the new areas. Okay. Suppose they had asked you, what is the ratio of the original CSA to the new CSA? What you need to do is that original CSA was 4 pi R square. The new CSA is this. Correct? So, 4 pi R square and 4 pi R square into 9 by 16. So, divide 4 pi R square by the new one. You will get 16:9. This is the ratio. But in the question, they did not ask about this particular ratio. They are asking by what percentage will the CSA decrease. Okay. Suppose you have got 80 marks out of 100 in a test. Okay. Your next test, your mark became 35. Unfortunately, How many marks did you get reduced, or by what amount, or by how much mark your marks got reduced? It is 80 minus 35. You will not do 80 by 35. Correct. It's the same thing. By what percentage will the CSA reduce means you need to find the old area. You need to find the new area. Subtract them first. Okay. So let us see what we are getting. Original radius is R. The new radius is 3 by 4R. You know how to find it out. Area is 4 pi R square. Here my area is 4 pi R square. So my R has actually become 3 by 4R. When I am squaring it, I get 9 by 16 R square. I need to find the decrease, which is the old area minus the new area. So decrease in the area, 4 pi R square minus this. 4 pi R square was common. I took it out. So I will get in the bracket 1 minus 9 by 16, which is 7 by 16. I cancelled out the common factors in order to get 7 pi R square by 4. This is the decrease in the area. Have they asked for the decrease in the area? No, they have asked for the percentage decrease in the area. The percentage increase or decrease is given by the new value, the change in value divided by the original value into 100%. So the formula is this. Now you need to understand that whenever you are trying to find out the percentage increase or decrease, it is always calculated on the basis of the original value. Because there is a change and there was an original value, and because we are trying to find out how much percentage it has changed from the original value, the formula is always based on the original value. Now when I am saying a change in value, it can be an increase or a decrease in the value. In this case, it is a decrease in the area. It is 7 pi R square by 4. So now let us calculate the percentage decrease. So as you can see, our percentage decrease in area is given by 43.75%. From this particular sum, what are the points that you know that you should remember? The first one, the formulas that you require, of course. Now, the second one, read the question properly. A small word, a by or a to, can change the entire question. So once you get it, if it is decreased by 25%, find the new radius. Reduce it to an understandable fraction and keep it. Find the original area, find the new area. When they are asking the ratio, it is new area by original area or original area by new area, however the ratio is asked. If they are asking for the decrease or the increase, subtract. Get the value. In order to find the percentage decrease or increase, it is always new value by original value into 100. So you get this. Okay. Now, can I slightly change this question so that you do now one more question of the same type, so you have a better understanding of the whole thing. So let us decreased. Instead of decrease, I will keep it as increased. $110%, okay, or decreased by 10%. Sorry, my bad. Okay. Now, by what percentage with the CSA change? Okay. Try to do it on your own. I will be doing the solution on the board. Then you can cross verify whether your answer is correct or not. So here you can see that I have completed the sum. Original radius, the new radius after 10% increase, I have added 10 by 100 R. You get 11 R by 100 after reducing. Old area, the new area. This is the new radius. So this is what I am getting. The change in the area is the new area minus the old area. So you will get 21 by 100 into 4 pi R square. The percentage change is the new value by the old value into 100. You will get 21%. The radius of a hemispherical balloon increased from 6 cm to 12 cm as air is pumped into it. Find the ratio of the surface area. This is a sum that is given in the NCERT exemplar textbook. In addition to that, I will be adding subparts to this particular sum, so you get a clear idea of the difference between the ratio, increase or the decrease, or the percentage increase and the decrease. Okay, so here you have find the ratio of the surface areas, change in surface areas. Third one, percentage change in surface area. Okay, now let us start with the first one. The radius of a hemispherical balloon increases from 6 centimeters to 12 centimeters. So I have the balloon. This is my original. This is a new one. My first radius is 6 centimeters. My second radius is 12 centimeters, which means the balloon has gotten bigger. So the surface area automatically has to increase. Let us see whether it is the same case here. My area in the first case will be 3 pi into 6 square. In the second case also, the formula is the same, but the radius has changed into 12 square. We need to find the ratio of the surface areas. So, original area by new area, okay, will be 3 pi into 6 square by 3 pi into 12 square. You will get, or 6 into 6 by 12 into 12, where you will get it as 1:4. The new area is 4 times the original area. The first part is done. Now the second part, change in the surface area. Now when you say change in the surface area, it basically means increase or the decrease in surface area. In this case, it is an increase in the surface area. So here you will write change or the increase in area is equal to 3 pi into 12 square minus 3 pi into 6 square, okay, which is 3 pi into 144 minus 36, right? So 3 into 22 by 7 into, correct, 108. Okay, now let us see whether this is divisible. You can see that it is not divisible by 7. So you will get 3 into, okay, and you find the value in order to find the change in the surface area. Okay. Now the third part is the percentage change in the surface area. I have already told you that the percentage change is always given by the change divided by the original change. The change is this value divided by the original value into 100. Now let us see what is the value that we are getting for the percentage change in the surface area. So you will get the change or the increase in the surface area as 1018.29. This is an approximated value. The reason being it was not properly divisible by 7. Now we need to find the percentage change. Now the percentage change is given by the change divided by the original value. Now instead of taking the change in this way, I have taken this particular thing. The reason being 108 is divisible by our 36. So this is the change in area divided by the original area. So 3 pi and 3 pi got cancelled. 108 by 36 is a 3. 3 into 100 is a 300%. So the same sum can be asked in a multitude of ways. They can ask the ratio, they can ask the increase or the decrease. They can also ask the percentage increase or the decrease. I hope you are clear with it. So have a very clear idea about what the question is about and then you start doing the sum. Okay. A hemispherical dome of a building needs to be painted. If the circumference of the base of the dome is 17.6 centimeter, find the cost of painting it at the rate of rupees 5 per centimeter square, 100 centimeter square. Now, we are given the hemispherical dome. You have seen domes on the top of buildings. We need to paint the dome. And what is given to us? The circumference of the base is given. Now, let us start breaking down the sum into small parts. So we can finally combine all of them together in order to get the required answer. So what is given to us? A hemispherical dome. So we have a hemisphere. Okay. It needs to be painted. I told you whenever you need to paint something, plaster, cement, it is always the area. Now if you are again having a doubt whether it is the area or the volume, I told you to look at the unit. You need to paint it at the rate of rupees 5 per 100 centimeter square. So if you find the volume, you will get it in centimeter cube. So this value will not be of any use to you. So we need to find the area. Now the question arises, should we find the total surface area or the curved surface area only? You know the domes cannot be hanging in the air. It has to be fixed. So the base will be fixed. I cannot paint the base. So I need to take care only the CSA. Now what is the CSA of a hemisphere? Now we have a problem, we do not know the radius. What is given to us? Circumference of the base of the dome is given to us. What is the shape of the base of this hemispherical dome? It's a circle. What is the circumference of a circle? It is, can we find the radius? 17.6 divided by 2 pi. 17.6 divided by 2 into 22 by 7. Find out the radius and substitute in this particular formula. So let us complete the sum. I want you also to do the sum and cross verify the answer. After solving, you will get the radius as 2.8 centimeters. Let me substitute it in the area. So area is given by 2 pi r square. So you can find out the area. So after substituting in the area formula, I am getting the value of area as 492.8 centimeters square. Now let us calculate the cost. You know that 5 rupees is for 100 centimeters square, right? So for 1 centimeter square, unitary method, this is 5 by 100. So for the area which is given to us by 492.8, it is 5 by 100 into 492.8. You will get rupees 24.64. I hope I have got the decimals correct. Let me check again. Yeah, so it is rupees 24.64. So this was a very easy sum actually. We were given the shape. We needed to find the area, which was only the CSA in this case. Because the base of the hemispherical dome was fixed, then we found out the radius from the circumference of the base, which is a circle. So in order to do all these sums, you need to have a very clear idea of the shape that you are dealing with. So whenever you are studying, you know at least a rough diagram of the shape. Not in the examination paper, but only when you are studying in your house, draw the diagram so that you get a clear understanding of the shape that you are dealing with, especially because you are drawing the diagram. So when you are drawing the diagram, you will know what you are drawing, though it doesn't look like that, but you will know what you are drawing. Okay, so what I suggest is that in wherever possible, however silly it might look, please draw the diagram. We have already done a few sums related to the surface area of a sphere as well as a hemisphere. Now, whenever we were doing sums regarding the hemisphere, we were dealing with proper solid hemispheres, whereas it's a completely filled solid. There is no empty space. Suppose the inside, suppose this is a hemispherical solid, and if from the insides are scooped out, what do you get? You get a shell-like thing in the hemispherical shape. So such a shape or such a solid is called as a hemispherical shell. So, okay, internal radius r and the external radius is capital letter R, just like in the case of a cylinder. Now, I told you area is all the places where you can run your hand. I can run my hand on the top. I can run my hand in the inside also. So I will have an area of 2 pi r squared as the outer area plus 2 pi r squared as the inner area. Okay, I hope you have understood. Let us do a few sums with respect to the shell. The internal and external diameters of a hollow hemispherical vessel are 25 centimeters and 24 centimeters and 25 centimeters. The cost of painting 1 square meter is given to be rupees 10. Find the cost of painting the vessel. And they have also told you to ignore the edges. So edges means this is our shell. This part they have told us to ignore. Now internal and external diameters are given to you. So our internal and external radii will be of 12 centimeter and 25 by 2, which is 12.5 centimeters. So this is 12 centimeter and this is 25 by 2 centimeter. Okay, now we need to find the cost of painting the entire thing. Now I told you that the total area is the external area plus the internal area. The external area, which is this area, is given by 2 pi r square, and the internal area is given by 2 pi into internal radius square. Now let us substitute the values and see what we are getting, and then also the cost of painting. Okay, so I am substituting the individual values in the formula. So you will get the external radius 2 pi r square. So this is external area. This is the internal area. I told you whenever there is a common factor in calculation, take it out. 2 2 into 22 by 7, I have taken it out. Remaining 25 square 625 by 4 plus 144. I have taken the LCM and this is what I am getting. So unfortunately our number is not properly divisible by 7. So I will not be dividing it now because I don't want to approximate anything. I will divide it only in the last and final calculation. So what is our last calculation? Find the cost of painting the vessel all over at the rate of rupees 10 per 1 square meter. So now this is in centimeter square. We need to convert it into meter square, or we need to convert this meter square into centimeter square. Right, as I told you, you can directly use the conversion formula or you can convert it in your own way. Okay, so let us see what we are getting. Instead of using the direct formula, I have used the step-by-step method. So rupees 10 for 1 meter square. 1 meter square is 1 meter into 1 meter. I converted it into centimeter. So rupees 10 for so much centimeter square. This is our formula. Okay, now for 1 centimeter square, this is what we are going to use. So for this much centimeter square you will get. So it is 13.21. The internal and the external diameters of a hemispherical vessel are 24 centimeters and 25 centimeters. Find the total area. Now what is the difference between this sum and the previous sum? In the previous sum, in the bracket there was a statement, ignore the edges. You need to check out such important things which are mentioned in the question and the questions in which nothing is mentioned, and see the difference between the two sums. See, suppose this is a hemispherical shell. Okay, now in the previous sum we found out the external surface area and the internal surface area of the shell. They told us to ignore the edges. So this area we ignored. In this case they are not telling you anything like that, which means that I need to take into account this area. Now this looks like of negligible thickness, but in a proper hemispherical shell this part will have some more thickness. So what does this part look like? It is a circular shape. Now again we have learnt in cylinders that this looks like a circular disc. So we need to add the area of the circular disc also, in addition to the external surface area and the internal surface area of the spherical shell. Okay, now let us see how to find it out. So now let us see what is the total area of a hemispherical shell. You have the outer CSA plus you have the inner CSA. Right? In addition to that, you have the area of the circular edges. Now, because the inside part is hollow, the circular edge, it will be like this. Okay, and here you will have the hemispherical shell. So when it is a circular disc, you will have the external radius r and the internal radius r. Which is the area we are concerned about? This part. This area is equal to, outer area minus the inner area. Outer area will be from here to here. Inner area will be from here to here. So from the outer area, if I subtract the inner area, I will get the area of only the circular part. Okay, so I need to add that particular area. This is the minus sign. So this area to the outer CSA and to the inner CSA. Okay, so now let us find out the final answer. So this calculation I have written over here. I have taken pi, which is a common factor outside. I will get 2 into 144 plus 2 into 625 by 4 plus 625 by 4 minus 144. So 2 into 144 minus 144 is 144 plus 2 into 625 by 4 and 625 by 4 is 3 into 625 by 4. So I hope all these things I don't have to explain. Basic calculations. Pi is outside. I have taken the LCM. This is what I am getting. I added and I am getting that 22 and 4. I can cancel a common factor of 2. So I will get 11 by 14 into 2 for 5 1. I multiplied these two and I am getting this. And there I had to give into normal division, and this is what I have gotten as the area.